Hi guys and girls on YouTube, and welcome to my channel. In this video we're going to be looking at a Doric Redifusion vintage colour TV dating from about 1978, 1979. Now I've just recently acquired this from John Joe, who's got the vintage Irish TV and radio channel on YouTube, and if I can get my daughter to help me put a link on, we'll place a link at the end of this video. Now I think I heard him say that it had frame collapse, but I've not plugged it in yet and I've not taken the back off yet, because this is a set I've largely forgotten about in the passing of time. But I do very clearly remember actually repairing at least one of these, and it was before we had the shop when we worked from home, so it would be probably 1984 or thereabouts, and there was a capacitor in the line output stage with a dry joint, and it had actually damaged the capacitor. So the actual capacitor in question was one of these big blue ones, and I actually replaced it. I didn't have one of these, I just replaced it with one of these, the same value, same voltage, and it worked absolutely fine for a couple of minutes. And then this capacitor I put in, it got so hot that it actually melted in front of my eyes. Now what I didn't realise at the time is thyristor line output stages pull an enormous amount of peak current through these capacitors, and I think in the end I had to order the proper one from the manufacturers to get 100% cure for the fault. Now I can only remember a Redifusion Mark III and a Redifusion Mark IV, but that's not to say there were other ones, I just can't remember, it's such a long time ago. But if we take a look at this, it's in remarkably good condition apart from a large chip there, and also it seems to have had another panel mounted on here that's screwed on. Now I can't imagine why that would have been added, but it's got some search tuning buttons on, and they look like they might have come from an Hitachi set or a Solora. Now I seem to remember on one of these there was a remote control version where the actual button flicked out, and it was like the Fidelity with a relay on the back. So what I've done is I've gone through my service manuals and I've pulled out the only two manuals I've got for Redifusion, the Mark III and the Mark IV. So we'll take a quick look at them and then we'll get the back off. So these are the original manuals from my old shop in the 80s. That's the Mark III, that's the parts list and the circuit diagram, and I've also pulled out here the Doric Redifusion Mark IV. Well, let's just get this out of the bag first. So when we look at the circuit description here for the Mark IV, I've actually made quite a few handwritten notes on the front here. So I must have done quite a few of these tellies over the year and just forgotten about them in the passing of time. But I've still got all the documentation here. There's some sort of modification there for, looks like it's a different chip or something on the field output. That's another diagram in there. Now I think the Mark III had a thyristor line output stage, and the Mark IV had like a conventional BU208 transistor. But let's get the back off the telly. I'll reform the main smoothing cap, and then we can have a quick look, see what actual chassis we've got, because I've really no idea to get the back off. Right, so I've established now we've got a Redifusion Mark III. Now I've taken a little while to look over this circuit, this diagram. There's some very quirky circuitry. If we look down there, we've got a little mains transformer, and it says startup circuit, and if you follow that round, it feeds 29 volts to the power supply regulating thyristor, and also up here we're also feeding 29 volts to the line oscillator. Now once the line output stage comes into operation, this diode here is reverse biased. Let's follow that up, and the 29 volt rail is actually comes from the line output stage, so it's flyback rectified there. So that's a bit odd, to use like a separate mains transformer just to start the setup. And if we look at the time-based panel there, the over voltage trip, when the gate of this thyristor gets to, I think it's 33 volt, it just shorts the line oscillator supply to ground through that resistor. Now there, instead of a Zener diode, what you'd expect, we've got a TAA550, I think that's a 33 volt, or 30 anyway, 30 or 33. That's a 2-pin tuning volts regulator. So that's a bit unusual there, to have that instead of a Zener diode. And if we examine the frame output stage, the field oscillator there is a cross-coupled multivibrator, but there's no actual field hold control in it. So whether it's synchronised by a pulse here coming from the TDA 9400, but it's very unusual to not have a field hold control. Right, so that's the back off the telly. I don't actually remember any of this now, it's such a long time ago. So let's have a quick look. That there will be the regulating thyristor for the power supply. 2 smoothing cans, that's the little start-up mains transformer I was telling you about. We've also got a linear line linearity control there, so we've got some of the line time base on that panel as well. There's an interesting modification there, I might have to look into that. I'm not sure what that is. That's the decoder and red-green output panel, and if you notice there, presumably that's just the main HT rail. Somebody's tapped off with a resistor, and that seems to go up to that new panel that's been added, and also there's a chip on there, look, probably for search tuning. So this set's been modified, or at least the tuning part's been modified at some time during its life. Now what you can't see from the back is the line output panel and the frame panel, which is obviously behind here. So if we do have frame collapse, this is going to be a bit of a nightmare to work on, because you can see the boards on this side, and then if we lower it down, the line output stages under that can, I'll just whip them nuts off and we can have a look under there. That's the frame panel right down there. So I don't know how on earth you get into there to make any oscilloscope measurements or any voltage measurements. That appears to be the IF panel, and we can see there that some wiring's been altered, and that presumably, yeah it does, that goes up to that panel with a chip on. There's the degaussing resistor, and it just has an ordinary Loring switch, it doesn't have the one I was talking about with a relay on the back. So let's see what CRT we've got. A56 615X made by RCA. So what I'll do is I'll get a 4BA nut runner, and we'll just take that off and just have a look at the line panel under there. Right, well that's my old 4BA nut runner. Incidentally, a lot of TVs in the 70s use these 4BA nuts, so we don't need to take these out completely, just loosen it off, and then this should slide up. Right, so I'll get a bit more light on this. You can see the 2 line output thyristors there, the scan and the retrace. Let's shine some light into there, and you see what I mean now about these big blue caps. That one is only a 0.22 microfarad, that big one, and there's another big one there. Tripler line output transformer. I don't know if this light's doing any good, is it? But I mean, how on earth do you get to that time base there to do anything? Right, so I think what I'm going to do, I'm going to whip the power board out first, and then we'll just reform these 2 caps, and then we'll go for switching it on, see what happens. Yeah, I don't know whether that light makes it worse or better. Anyway, you've had a look at it now. Let's get the power board out. Right, well that was easy enough to do. Just 4 plugs to unplug. No, sorry, 1, 2, 3 plugs to unplug. Loosen that 4BA nut there, and this just slides up and comes out like that. There we go. And that also gives us the perfect opportunity to check for dry joints on the back of here as well. And I would imagine most of the dry joints will occur down the bottom in the power hungry line stages. In fact, I can see a dry joint there already. That is, if we turn that over, it's on 6L4, which according to this is the east-west modulator transformer. So I'll just go over them first. Now, on the basis that this set must have worked like this at one time, I'm just going to leave that in for a moment, because this resistor here, marked 6R14, according to the manual there, it's 47k, but the colours on that aren't 47k. And the one strapped across it's 27k. So I really don't know what's going on there at the moment. It's definitely the right number, 6R14, but I'm just going to leave that for a moment. We'll come back to that when we've when the set's fired up and see what we've got. Right, so just before we turn this set on, I've cleaned round the anode cavity there because we don't want any arcing when it comes on. And I can actually see what's happened to this set now. The tuning drawer's missing. This would have been a manual TV, and somebody's converted it to a remote control TV. Because if you look down here, you can't see it very well, but down there there's an infrared sensor connected to that board. So this was a manual telly, and now it's a remote control telly. And if we turn it round to the front, you can actually see there where somebody's drilled a hole in the front to let the infrared signal in from the remote control. So I wouldn't have thought this was a Redifusion modification. I would imagine that this has probably been bought surplus from somewhere like Manor Supplies, and it's been just used to convert this telly into a remote control TV. Right, so we'll turn it round and let's get it powered up now and see what happens. Right, so the set's plugged in. I'm just going to switch it on here so I can stand back, and let's see what happens. Oh, channel display's lit up. I could hear the EHT, and yes, we have a frame collapse. Yeah, absolutely perfect frame collapse there. Right, so at least it's powered up anyway. The next thing to do, turn it off so we don't burn the screen, is how we're going to get to the frame panel now to make any measurements. Right, so the fact that the width's in at the sides as well tends to suggest that the east-west modulator's not working as well. Now, the supply for the frame multi-vibrator is of the 29 volts, obviously there, because it comes through this 330 ohm resistor, and it also feeds the line oscillator. Now, because we've got EHT, we know that's running, so we can almost certainly say that that's there. Now, the frame output stage is pretty conventional. You've got 2 transistors. This is the east-west modulator. If we look at this, this is fed from a 32 volt supply. So if we move across here, down there, right, so the 32 volt supply is line scan derived. So it comes off the transformer winding pin 3 through a fuse, current limiting resistor, BY298 rectifier diode, and it's smoothed off there. So I would say that we have this supply missing. Now it could be the fuse, or it's more likely to be a dry joint, probably on the transformer. So I'll just check the fuse first, and then if that's in order, we're going to have to get this panel out. The line output panel's going to have to come out. Right, so you can see one fuse there, the other one's just behind it. Both of them fuses appear to be okay, so this whole panel's going to have to come out. So it looks like we just undo 4BA nut there, unplug 1, 2, 3 plugs, and all that panel comes out. Right, so that's the panel out. I can't really see any dry joints. And of course there's no screen printing on the back, which makes it a bit more difficult. So I'm just going to do some cold checks now with a meter. Right, so that's a bit more workable now. I've actually unplugged this connector to the tube base panel, so I can actually get the board out a bit further. So that's the 2 fuses in question, they're both alright. I've got to find the rectifier diode now. In fact, I've just noticed this capacitor here, 470 mic at 350 volt. There's a white powdery deposit there, so it's, I would imagine that's dried up. But if we look at the diagram, it's off the line transformer, it's rectified, a 270 volt rail, so that will only be to the video output stages. So if that is indeed dried up, it'll just give us an over bright picture. But my quest now is to find that resistor and that diode, and we might even need to check that cap as well. Right, now all these parts here appear to be in order, so somewhere we're going to have to try and measure voltages. I'm not just sure how we're going to do it, but we want to look at that first. Right, so with great difficulty I managed to confirm that that voltage is present. Now it's 36 volt, presumably because it's unloaded. So now we're over to the field output panel. How on earth we're going to work on that, I've no idea. So I think the best thing to do is just take it out and make some cold checks on that as well. Right, well that's the frame panel, that came out easy enough. If you look behind it, it doesn't appear to have had any work done on it in the past. So the first thing we're going to do is check the scan coupling capacitor there, and just see if that's okay. After that, I don't know what we're going to do, because I presume in its day they must have had extension leads to plug in here so you could work on the panel on a bench. Anyway, let's do some more cold checks and see what happens. Actually, what I have just noticed is there's no frame output or east-west modulator transistor on there. They must be mounted somewhere off the chassis and plug into one of these connectors. Right, so 2 safety resistors there, one there, one there. Now if you look at the diagram, move that out of the way. So that's the earthy end of the field scan, and it's returned to ground through that 0.47 ohm. So this is part of the feedback circuit for linearity. So 270 ohm resistor, that is open circuit, and also the base bias resistor for the lower frame output transistor, that is also open circuit. So it's pretty safe to assume that these 2 transistors, or at least one of them, is probably faulty. So all I've got to do now is find where they are. Right, so if we lift that up, the frame output pair of transistors and the east-west modulator driver is on this panel here behind the aerial socket. So if we drop that down, that's the frame, and that's the east-west. Now luckily, because that's in a terribly inaccessible position, luckily all them 3 transistors come out on this plug and socket, so that should make testing them a lot easier. Right, so that's how you get to the frame output transistors. You take off the aerial socket. There's 2 screws there, there's 2 screws there, 2 behind the time base, 2 behind the decoder, and this panel all drops off. Now both the output pair there and the east-west modulator transistor, they're all alright. So the fault is on the time base board, so I'm going to wrap this up for now. I'm going to put that back in, and we'll come back to it another day. Right, so we're back onto the rediffusion again while we wait for a parts delivery for everything else. Now I've checked over on this time base. I cannot find any reason why these 2 safety resistors should be open circuit. Both the output pair okay. It appears to be driven by a constant current source. All these transistors and diodes are okay. The scan coupling capacitor, where is it there? That's okay. So I really don't know what to tell you. The only thing possibly, well, I guess there's 2 things. It could be that the HT rail is too high, and it's listed there as 300 volt. But then you would have thought if the HT rail was too high, the LT rail would have also risen, and we'd have tripped the overvoltage trip and stopped the line oscillator. So I really don't know. But another possibility is, if we look into the back of the cabinet there's a lot of white deposit, and that tends to suggest that this set's been kept somewhere in damp conditions. So I wonder if it's just a surge when it was turned on that blew the resistors. Perhaps somebody tried it before I did and the resistors went at switch on. So the only option I can see is to just put 2 new resistors in, and we'll turn it on and just see what happens. Right, so I've dug out me 2 drawers full of safety resistors from the 1980s. Let's just see if we can find the right values now. So I actually need a 270 ohm and a 100 ohm. Now you would have thought with all this stuff I've got I could find 2 safety resistors, but no, I cannot find 2 of the correct value. So we're just going to have to make something up. Right, so there I've got a 22 ohm and an 82 ohm in replacement for 100 ohm, so that's 104 ohm. That's as near as damn it. I've just got to find one for the 270 ohm now. And for the 270 ohm, the best I can come up with is an ordinary carbon film 270 ohm resistor in series with a 0.33 ohm safety resistor. So that's them 2 in. But I've just had another thought. This lack of width still playing on my mind, and I'm wondering, given that we found a dry joint on the east-west modulator transformer, I think before we put the time base in, we should locate that 10 ohm resistor there and make sure that resistor is not going to open circuit as well. Right, so 6R11 10 ohm, that's there. I've tested that, that's okay. The east-west loading coil doesn't look distressed, because usually when you get an east-west fault, these inductors will melt and get shorted turns, but that looks okay. So I think the only thing we can do now is just reassemble it and plug it in, see what happens. Cross your fingers, hope for the best. Right, so I think before I switch on, I'm just going to drop the mains down to 80% with a variac before we turn on. So I'll set the camera up on a little tripod. That's about it. And here we go then. I've unplugged the speaker on the telly because for some reason the volume seems to have come on full. But let's turn the brightness up a little bit. And here we go. Well, channel displays come on. Ah, we have a raster. Right, now, oh, it's tripping the variac. So, although we had a raster, that was quite short-lived. Anyway, we're getting there. Yeah, something's gone off, and I'm not even sure if I can't smell a slight smell of burning. But if we turn it on and listen to the variac doesn't like that, and also the 300 volt HT rail is very low and pulsing. So I would imagine something's gone off in the line output stage. Right, well, I've still not got this set going yet. I'm still trying to get my head around this, wondering if there's some sort of a problem. So the resistor on the board is marked 6R14, and it appears to be 150k. Now, when we look at the manual, 6R14 here is listed as 47k, but I look at this parts list here and it says since the main service manual was published, a considerable number of component changes have been made to improve reliability. So I'm going to look in this parts list what that resistor is listed in there. Now in this parts list, 6R14 is listed at 150k. So this diagram must be slightly different. This must be an earlier one and this parts list must be a later one. So whether I've got a diagram missing, I don't know. But I'm just going to take that resistor out and check the value, see why somebody shunted it. I would imagine it's risen in value. Right, well, I really don't know what to make of that. It is 150k. I'm going to put a new 150k in. But I can't imagine why it's been shunted with a 27k. So I'm going to put this in. I don't think it's going to come on when I put this in, but I'll just try this, and then if not, I'll have to do some of the work and come back to it. Right, so I've disconnected that 27k shunt across it. That's the 150k resistor, and the 150k resistor is completely open circuit. So if it was fitted with 150k, if it was fitted with a 150k resistor and that was open circuit, why would you put a 27k across it? It doesn't really make sense. Anyway, I'm just going to put this new one in. I'm not too hopeful, but let's put this in and see what happens. Right, well, as you'd expect, changing that resistor made no difference whatsoever to the fault. Now, I've also changed a couple of resistors here in the error amplifier because they would have a significant effect on the regulation if they were high in value, and in fact one of them wasn't high in value. So let's turn our attention now to the power supply, and I'll run you through what's happening. So the mains here comes into this thyristor, which is configured as an electronic trip, and there is a resistor there, 6R3 10k. It's listed as a safety resistor. Now if you look in our set here, the actual safety resistor is very burnt. Now that is significant, and that is a very significant factor pointing to what could be the problem. So I'll just what I'll do, because it's hard to read this diagram, I'll just redraw it on a piece of paper and I'll run you through the significance of that resistor burning. Right, so if you remember what I said earlier on, the line oscillator is fed from a separate transformer. So the line oscillator starts as soon as this transformer is energized, but the power supply doesn't start straight away because of the electronic trip. So I've made this massively simple diagram. I've omitted quite a lot of stuff in there just to give you a basic idea of what happens. So when mains is applied to the set, the line oscillator starts via the standby transformer, but then mains is applied to this 10k safety resistor, which is the one in our set which is burnt, and that charges up this 1500 microfarad capacitor relatively slowly. Now when this point here gets to 6.2 volt, this Zener diode is actually this Zener diode conducts, and it actually feeds a trigger pulse to the electronic trip thyristor, and that turns the thyristor on, and then you get 300 volt appearing at this point. Now as soon as 300 volts here, bearing in mind the line oscillator's already running, the line output stage should come into operation, and via a winding P on the line output transformer, pulses here are integrated and fed back to the gate of the thyristor. So now this diode is reverse biased, and the thyristor is fed with constant pulses from the line output stage. So as soon as the line output stage comes into operation, that feeds the gate with trigger pulses. This startup circuit turns off. Now if for any reason the line output stage does not come into operation, this will constantly keep charging this capacitor and firing the gate of this thyristor to attempt to restart the set. And that's the significance of that resistor. The fact that it's burnt almost certainly means that in the past this set has suffered from some starting up problems. It's been reluctant to start on quite a few occasions, and if it's left in this condition, continuing to fire the thyristor with no pulses coming back from the line stage, eventually this resistor will burn out, and that stops the set completely. So that's what you see happening here with the burnt resistor. That indicates that this set's had a history of not starting up in the past. So I think what I'm going to do now is, so we don't burn the resistor out trying to restart it, I'm going to remove that fuse there, and we need to check that the line oscillator is actually running, and then we'll take it from there. Right, so the line drive output from the TDA 9400 is on pin 2. So if we follow that round, because this is on a separate board now, if we follow that round, it comes to here, and then it passes through a plug and socket into the frame output panel, and it passes through another plug and socket there, and it comes into the gate of that thyristor there. So there's multiple points where we could actually measure the line oscillator. Ideally we need to be measuring the gate of that thyristor, because if you look at this, that is the line oscillator panel. It passes into the frame, and then it comes out of the frame, probably on this connector here, onto the time base. So we need to be scoping that line drive waveform on one of these thyristors. I'm not just sure which one it is. I'm going to have a look. Right, so that's the fuse lifted here. The whole of this power supply panel will now be dead. The only thing we'll leave running is the standby transformer. Now just an interesting little thing here. I mentioned the startup resistor charging this capacitor here. So let's just, you would expect that capacitor to be near this resistor. Well, that's what you would have thought, but let me just show you. That's the startup resistor, and if we move right back, the capacitor it's charging up is here, right down in this bottom corner. So I don't know why you put the cap there and you put the resistor right at the other end of the board, but anyway, these strange things happen. So now we've got this power supply dead. I'm going to power it up to energize that transformer. I'm going to scope the gate of the thyristor and see if we've got any line drive. Right, so now the scope is connected to the gate of thyristor 5ITR1. I'm going to switch on here. Scope probe under there. Here we go. Right, so we do have line drive at the thyristor's gate. Now that's really, really bad news because that means the problem is in the line output stage. Now, just in case you're wondering, I've already disconnected the tripler. That was too easy. That's not the problem. So we're in trouble now. We're going to have to get this board out and take a look at those thyristors. I once did have a very similar problem in the Normandy 3787, and it was shorted turns in the commutator coil, which I haven't got any parts for this anymore now. So right, we're going to have to get that board out now, make some cold checks on them thyristors then. Right, so that's the board on my bench. Now, the most obvious cause in the line output stage would be one of these thyristors going faulty. So that's the one that we're going to be looking at first. In fact, if you look at it, if you look at the soldering there, this appears to have been soldered at one time. So I would imagine in the past that's already been changed. If you look at the other one, that's as it came out the factory. So it's almost certainly had this thyristor replaced in the past. Now, I can't even remember what's under these covers now. We're just going to have to take it off and have a look. But we could be in trouble with this now. Now, it's such a long time since I actually tested a thyristor. The battery's gone faulty in my peak tester. But anyway, I put a new battery in. We hooked up to the thyristor. Let's see what it says. No silicon control rectifier or triac detected. So that would indicate that that thyristor is faulty. So what I'm going to have to do is take it out now and see what it is. Interestingly enough, it says there's no thyristor detected on the other side. Now, whether that's because it's got an internal freewheeling diode and this tester doesn't test with internal diodes, I'm going to have to look into that though. I mean, there is a possibility they both could be faulty, but for now we're going to come back to it. Actually, I think at this point it might be a good idea as well to just take out the line output transformer, and we'll see if we can test that as well. Right, so that's the transformer out. I might even take the tripler out as well, and then we can just give a good clean round it. So I think what I'm going to do now is run some tests on this transformer, see if that comes up with anything first, because we don't actually know if the thyristors are working or not, and if they're not working, which the tester says they're not, but I'm not 100% sure about that. You've got to think, if they're not working, what's killed them in the first place? And the obvious thing would be the line output transformer. So I'll stop the camera for now and we'll come back to it another day. Right, back onto the rediffusion for a few minutes. I've got some bad news. I think the transformer's died. I'm going to have to run some more tests on it. I haven't quite established yet whether the thyristors are operational or not, because I thought while I get the transformer out, we'll run some tests on this. So let's just have a look at a quick test on a transformer and I'll show you what you're looking for. So I can't find a transformer that doesn't have a rectifier built in. So I'm just going to run this same test on this transformer. I think this is out of a Thorn TX90, but let's just see on this one first, because it has the same effect anyway. So for this little demonstration, I've just turned out the light, but look at the underside of this transformer when I energise it. So if you look at that, it's producing EHT everywhere. There's that much coming out. Now if I run the same test on this rediffusion transformer, it's just completely lifeless. There's no life at all coming out of it. Now I'll just do one more test. I'll do a ringing test on it, but it almost certainly looks like it's died on me. Test number 2. Let's connect the transformer here. As you can see, the transformer died. So I might just try one more thing, and then I think that's really all we can do then. So just for a quick demonstration, I'll demonstrate the ringing test on this Ferguson transformer. So if you look at them, we've got a load of lights. When we connect the transformer to it, if it can maintain oscillation, you'll have a green light lit. And there we go, you see. Lights right up to the green. But on the rediffusion one, when we connect it, just kills it altogether. So yeah, 3 different tests, confirmation that the transformer has gone. Now there's a part number, it's made by ITT, it's a FAT 1109-741-57, and back in the 80s, when you wanted one of these, you just pick up a catalogue and you'd order one, but sadly now no chance of getting anything like that. So what we're going to have to do is just put this set to one side for the moment. Now I do have buried, and I know where it is, it's buried in the other room, another rediffusion set, but because I can't get at it, I don't know what model it is. It might be the same one, it might be completely different. Whether it'll have the same transformer in, I really don't know. But I think for now we're going to have to call this part 1 for this video, and if I ever do get this set going, then we'll make a part 2. But for now, it's unfortunately come to an end. Alright guys and girls on YouTube, many thanks for watching, and I'll catch you in the next video.